10 multiple choice questions here for the new style of OCR exam. So all I'll do is slowly scroll through the questions. You can pause the video and have a go at the answer, and then I'll go through the answers in the second part of the video. So the first question, how many electrons are there in this ion of magnesium? So the important numbers to look at is the 12 there, that's the proton number. So before it lost any electrons, see it's lost 2 electrons, it had 12 electrons, but because it's got a 2 plus charge, it's only got 10 now, so the answer is 10. Formula of chromium 3 sulfate. So the fact that it's chromium 3 means it's Cr3 plus. The sulfate ion has a 2 minus charge, and so to get the charges to balance each other out, we need 2 of those and 3 of those, and so the answer was C. Which of the molecules is non-polar? So you can see I've written up there, it must have no overall dipole, i.e. be completely symmetrical, and so the dipoles cancel. So all I've done is sketched up what these molecules would look like, and you can see straight away that these 3 here have got lone pairs. This one hasn't. This is the non-polar molecule. So the answer was A. Which row was correct? So the highest pH when added to water, you can see I've written there, these group 2 oxides get more alkaline down the group when they're added to water. So barium oxide is more alkaline than magnesium oxide. So we can rule rows A and B out. Which is the most reactive halogen? Well, the most reactive halogens are at the top of group 7. So fluorine's more reactive than iodine. So the answer was row C. Which equation represents a redox reaction? Redox involves reduction in oxidation processes, so we need to work out the oxidation numbers of everything. They've been quite nice here because the first example is actually the redox reaction. 0 oxidation number for magnesium at the start, going to +2, so there's your oxidation process. The hydrogen is in +1 oxidation state in HCl, and it drops to 0. So there's your reduction process. So we've got both processes, and therefore this is redox. So we didn't need to look at those. Right, in fact, I make it quite small just so you can see the whole question and my notes here. So which trend is correct? So melting point decreases from lithium to carbon. So no, the melting point increases from lithium to carbon because lithium's metallic, quite high melting point, but carbon has a giant covalent structure with a really, really high melting point, and so that statement's not correct. Boiling points decrease from fluorine to iodine. That's not correct because you can see there the melting point of the halogens increases down the group. The first ionization energy decreases from lithium to cesium. First ionization energy is decreased down every group. So that is actually a correct statement. So the answer is C. We'll just talk about D. The first ionization energy is increased from nitrogen to oxygen. Oxygen's one of those dodgy ones where the first ionization energy actually drops a little bit, and so that statement isn't correct. So the answer was C. Empirical formula. So what's the correct empirical formula for compound M? So you have to quickly knock up an empirical formula table for your three atoms, carbon, hydrogen, nitrogen. Put your masses in, divide by the MR. That gives you the moles. Make sure you go for at least 3 significant figures. Be very, very careful with your rounding. And that gives you a 1 to 4 to 1 ratio. And so the answer was C. Number 8, a student mixes 100 cm cubed of 0.2 moles per decimeter cubed sodium chloride with 100 cm cubed of 0.2 moles per decimeter cubed sodium carbonate. What's the total concentration of sodium ions in the mixture formed? So you can see I've taken the sodium chloride and worked out how many moles of sodium chloride I've got, and that's done by the concentration multiplied by the volume. Remember, volume must be in decimeters cubed. So there are 0.02 moles of sodium chloride, which means there are 0.02 moles of sodium ions coming from the sodium chloride. The sodium carbonate has the same concentration and volume, so the same number of moles of sodium carbonate, but because it's Na2CO3, there would be double the moles of sodium ions in the mixture from the sodium carbonate, so you can see that's 0.04. So altogether, we've got that plus that moles of sodium ions, so that's 0.06, and they're in a combined volume of 200 cm cubed, so that's 0.2 of a decimeter cubed. So the concentration, moles divided by volume, comes out at 0.3, and so the answer was C. Which mass of substance contains the greatest number of atoms? So we've got 3 grams of ammonia, 3 grams of chloromethane, 4 grams of hydrogen sulfide, 4 grams of hydrogen chloride. So you can see I've done mass over MR for all of those, and that's how many moles we've got of everything. Now these are the moles of the molecules. These are all molecules. So there's that many moles of molecules, and so the number of atoms present will be Avogadro's number times the moles of molecules multiplied by the number of atoms in each molecule. Hope that all made sense. So if we've got 0.176 moles of ammonia, we'd have 0.176 times Avogadro's number of ammonia molecules multiplied by 4, so we've got that many atoms. So we're going to do that for all 4 of these chemicals, and so you can see that the largest number is actually this one here, A. 4.24 times 10 to the 23 atoms, so that's the biggest of all of those, and so the answer was A. Final question, which reagent would exactly neutralize 100 cm cubed of 1 mole per decimeter cubed sulfuric acid? We've got all of these alkalis, bases to go on. All the same number of moles. So the first thing we need to do is work out how many moles of sulfuric acid we need to neutralize. So that's the concentration times the volume. So we've got to neutralize 0.1 moles of sulfuric acid. So, which is the right answer? So there's the first equation. So sulfuric acid reacts with aluminium hydroxide in a 3 to 2 ratio. And so to neutralize 0.1 moles of sulfuric acid, you'd need that many moles of aluminium hydroxide. For the sulfuric acid ammonia combination, you've got that many moles because of the 1:2 ratio. For the barium hydroxide neutralization, it's a 1:1 ratio, so 0.1 would need 0.1, and the sulfuric acid sodium hydroxide combination is a 1:2 ratio, and so you'd need 0.2 moles of alkali. So if we go back to the answers, the answer was C. You'd need 0.1 moles of barium hydroxide.